And also today we will continue with the next parameters that we are first we have seen the z parameter, y parameter, and now hybrid parameter and ABCD parameters. So hybrid parameters, the equation is actually different from the z parameter and y parameter, where you will have like a two, if equation one is actually based on v and another one at port 2 is actually based on the I. Okay, and you will have like a different unit for, like here you will have like a impedance, because P over I is actually impedance, and then I over I actually have like a current gain and reverse voltage gain, open circuit output impedance. So you have like different unit for different parameters. So H11 and H12 is actually not, both of them not impedance. Okay, one is actually impedance, another one is actually voltage gain. So the H parameter equivalent network of a two-port network will be given like this. So this is actually something important for the analog electronics. Okay, if you analyze the circuit based on the H parameter, sometimes you will analyze based on the pi network, so it will looks different. So here we have like an example where you will determine the H parameters of the following circuit based on the H parameter. I mean, so you will look at same, you will use the equation, eliminate one of the port. For example, say I1 you eliminate, means it will become like an open circuit. V2 at port 2 you will short circuit. Okay, to eliminate the V2. So when you eliminate this one, you will get the H11 and H21, and when you eliminate the I, you will have like a H12 and H22. That's actually like a conventional method we will use. And you also can create the port at without eliminating the port, keeping the port with this power source, either voltage or current. So based on that also you can solve like the alternative method we used before for the z and y parameter also can be done. Okay, so we will discuss the question in the discussion session. Just go through the slide first. Okay, then ABCD parameter, also known as a transition parameter. So here also you have like a what is that, different parameter for each of the A, B, C, D, all actually different. So here we have like a, it's actually known as a transmission parameter. So here you have like a open circuit voltage ratio V1, V2, and negative short circuit transfer impedance B, and the C is still known as the open circuit transfer admittance, and the D is actually known as the negative short circuit current ratio. Okay, here same, when we want to find the A and C, you have to turn off the I. I mean, turn off the I means open circuit at the port 2. And when you want to find the B and D, you will turn off the V2, which means you will short circuit. So both actually at the same port, nothing related to the port 1, both actually at the same port. Okay, so here we have like one example where you can find the ABCD parameter for this circuit. So this also can be done in this total session. Okay, the next thing that actually we will see in this chapter is actually the conversion of one parameter to another parameter. Okay, so for this conversion, like V equals to I, this is actually based on the what you call the derivation. Okay, you will have like so many things about the derivation, but in the exam you will just refer to, we won't ask you to derive for anything in the exam. So we will give the four table for equation for equation for each of the parameter, z parameter, y parameter, h parameter, t parameter. So if you forgot the equation, no need to worry, you can refer to the equation, and you can know by, let's say you use the conventional method, you know where to eliminate the source, which source you have to eliminate. This is actually open circuit, short circuit, open, short, this is short, this is open, but both is the same port if you want to use the conventional method. Or you can actually solve the circuit with the port, you keep the port there, you're not eliminating. by some analysis like mesh analysis or nodal analysis, you get the two equation, compare the equation and get the parameters. This actually usually we do. And two-port conversion, parameter conversion can be used with the table. This table also we give, for example, let's say you already have like a other parameter, like let's say you already have like a y parameter and you want to transfer to z parameter, this is z parameter. So that y parameter, you will use these equations for each of the coefficient, like y22 over delta y will be equals to z11, negative y12 delta y equals to z12, negative y21 over delta y equals to z21, and y11 over delta y equals to z2. So what is delta y? It's actually given here. So from y to z, from h to z, and from t abcd parameter z also can be done. Similarly for other parameter, like let's say I have a z parameter, from z I want to get the y parameter, or from the h I want to get the y parameter, or from abcd parameter I want to get the y parameter. Similarly for other parameters, you can get the h or t based on the other relevant parameters. Okay, this table also will be given in the exam, so we will look at one example, like how to convert the parameter. Okay, so the next, so this actually we will discuss in the example, or you can try, because conversion is not so difficult, you won't do any analysis. And the next part that we will study in this chapter is actually analysis of termination of two-port circuits, where you can do some analysis like power transfer. Usually we go to the maximum power transfer. So we will check the input impedance, output admittance, okay, and then the Thevenin voltage and impedance ZT and V Thevenin with respect to port 2, okay, current gain, voltage gain. Okay, so many analysis can be done, and this actually the what to call the derivation on how to get this, the parameters. Okay, Thevenin voltage, impedance, this and that, but we won't actually go through like in the derivation in the exam or anything. So what we will do based on the our our knowledge on how to get the Z Thevenin and V Thevenin. So based on our previous knowledge, we will get. So this is like voltage gain. Okay, so many things are here, but what we will do, we actually will focus on getting the maximum power transfer. You see, maximum power transfer. So for this maximum power transfer, we will find the V Thevenin, RL, and then the maximum power transfer. So for this, we will use the what to call our knowledge from the two-port network. So these examples also we will discuss in the discussion session or tutorial session. So so basically this actually what the chapter about. You will learn on what is that different parameter, means mainly Z parameter, Y parameter, H parameter, and T parameter. And for the last session, we will focus on getting the maximum power transfer using the V Thevenin, RL, okay, and also the parameters that we obtained here. So that's actually the overall process will goes on. Okay, so I end the session for this chapter 1. So in other videos we will see on how to solve the other example questions. So thank you.